Okay, so as far as how I teach a class similar to operations management, I follow this teaching philosophy. If I tell you, you'll probably forget. And then if I show you, you'll remember. So I will be telling, meaning for each topic that we cover in this class, I will be covering some of the important concepts in that particular topic or chapter. I will be showing you how to solve problems. So that will be the show me part. And hopefully you will also try to replicate the things that we do in class or the things that I show you. Because in problem solving, really, as you will learn later on when we learn the concept of learning curves, repetition will allow you to be more efficient at doing a particular task. So in this class, the more you do hands-on, especially using Excel as a problem-solving tool, the better you will become at applying or using those tools to maybe things that you do, not only in this class, but in your other classes as well. So I will involve you, and the involvement will come in the form of assignments. You have to work on those assignments so that you can have a better grasp of the process of solving problems, as well as improve your Excel skill. Now, this class will be mainly focused on the use of tools, whether we're talking about computer applications or models or formulas that you have learned in your other classes for the purpose of making decisions. All right, so the goal here is to for us to be able to, as business managers, be able to make decisions based on the tools that we have. So as far as decision maker is concerned, there are two kinds. There is the intuitive decision maker or thinker, and there is the analytical thinker. So as far as you are concerned, which of these two do you think you are? Do we know what the difference is between an intuitive and analytical thinker? What is the difference? Madison?
Intuitive is not really their own logic, but you're thinking based on what you believe, in a sense. And then I would say analytical is more like the logical thinker and like really going through the steps and really thinking things through.
Okay, good. Yep. That's actually a pretty good description of these two. So here's the definition that found on the web in terms of the intuitive thinkers. As Madison said, is something that an intuitive thinker is going with one's first instinct and reaching decisions that are based on automatic cognitive processes. So pretty much, maybe this when you're trying to evaluate a situation, maybe the gut feeling would you use as a way to evaluate choices, educated guesses, right? Whereas an analytical thinker is one that uses mathematical, scientific, or social principles to influence their decision making. So more perhaps using as a business person, maybe collecting data and transforming that data into information, and that information is used in the decision-making process. So this class will focus more on us being or applying the analytical thinking process to solving problems. Okay, so let's look at some scenarios or maybe questions, and then see where you are between these two, whether you're an analytical thinker or an intuitive thinker. So let's start with, this simple question. A bat and a ball cost $1.10 in total. The bat costs $1 more than the ball. Now the question is, how much does the ball cost? Doesn't this question remind you of your high school days when you did word problems in algebra? So who has an answer?
I mean, I have an answer, but I'm scared that I'm wrong for some reason.
That's fine.
I mean, the ball's 10 cents.
The ball is 10 cents, you said? Okay. All right.
The bat costs $1 more than the ball.
Right. So how much? How much does the ball cost then? So initially you said 10 cents. So how did you arrive at that? I'm sorry.
Well, I think I'm an intuitive thinker because I just read it really quickly.
Right. Yeah. So
and I didn't.
You're in the, as they say, was it in the ballpark? So anybody who has an answer, another answer? Elisa?
5 cents.
5 cents. Okay. So we have two answers: 10 cents, 5 cents. How did you arrive at your 5 cents, Elisa?
Well, if the bat is $1 more than the ball, then I made a formula in my mind, and then I thought if it was 5 cents, then the bat would be $1.05, and that would add up to $1.10.
All right, good. So you probably the formula in your mind was something like this. Let me see if I can. So to solve this problem using algebra, we will say, let X be the cost of the ball. So if X is the cost of the ball and the bat costs $1, we can express the cost of the bat plus the cost of the ball, that's the more than, the cost of the ball, in this way. And then to this, we add the cost of the ball. And the sum of these two is equal to $1.10. So from this point on, we solve for X. So we reduce this equation to become 2X plus 1 is equal to $1.10. And transferring 1 to the right-hand side, we have 2X is equal to $1.10 minus $1. 2X is equal to 0.1, and therefore we divide 2x by 2, and we do the same to the right-hand side. So we obtain x, the cost of the ball, as 0.05. a certain town is served by 2 hospitals. In the larger hospital, about 45 babies are born each day, and in the smaller hospital, 15 babies are born each day. So here's the larger hospital, and here's the smaller hospital. As you know, about 50% of all babies are born as boys. So in statistics, we call this sort of the a priori assumption. We know from maybe historical data that there's a 50-50 chance of gender of baby being born as boy or girl. However, the exact percentage will vary from day to day. Okay, sometimes it may be higher than 50%, sometimes lower. And in statistics, we call that sort of the random variation. All right, so here's the question. For a period of 1 year, each hospital recorded the days on which more than 60% of the babies were born as boys, okay, or maybe as girls. Pretty high, right? The question is, which hospital do you think recorded more such days, meaning recording more than 60%, in a day, 60% boys or 60% girls? Which one, the smaller hospital or the larger hospital? Brittany? Or
one.
Why did you say a smaller one?
Because it takes fewer babies to get to 60%. You only have to have like 9 of them out of like more. There's more variable in the larger one.
Okay, so in what you learned in statistics, this is the the law of large numbers. If you have a larger sample size, the variation from the true number, or in this case, proportion, will be much narrower than if you have a smaller sample size. There's going to be much more variation in the percentage that you will obtain. Okay, so that's good. So now you see in these 2 examples, we're looking at trying to answer problems using sort of the analytical way. In the first problem, we use maybe algebra. And then in this problem, we use our understanding of statistics. Okay, another scenario. Using one more time, our understanding of statistical concepts. A fair coin is tossed 6 times. Which of the following sequences has a higher likelihood of occurrence? Sequence A or sequence B? And it says, note that both sequences have 3 H's and 3 T's. Except that sequence A appears to be more random, quote unquote, and sequence B appears to have pattern. What is the answer? A, B, or C?
I took statistics in 2016, so this is just like probably a guess, but I'm going to say C because I don't think it matters what order they occur in. They both have 3 heads and 3 tails, so I think it's even.
That's correct. And there is a statistical concept that supports that answer. We're talking about independent events, right? So the probability of a head or tail occurring is always 50%. And as Phil said, the 3 T's and 3 H's, regardless of how they appear in the sequence, the probability will always be the same. Good. Another statistical illustration. A roulette table has 18 black slots, 18 red slots, and 2 green slots on the US roulette wheel. After a long run of red on the roulette wheel, you would conclude which of the following? A black is now due. A red is more likely. A black is just as likely to show than a red.
I mean, it's still just as likely to show.
That's right. Abby, and why did you say that?
Well, because I mean, the probability is the same. It's just always going to be the same. You just get lucky, I think.
That's right.
Gambling.
So again, this this is using the concept of independent events in statistics. The fact that maybe 5 black showed the 6th one, the probability of that 6th one will still be the same as what was that? 18 and 18, so half probability. Okay. Another one. I don't know if you've seen this before. Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car, behind the other is goats. You pick a door, say number 1, and the host who knows what's behind the doors opens another door, say number 3, which has a goat. Now the host then says to you, do you want to pick number 2? Meaning, do you want to switch your choice, or do you want to stay with your choice? So in this game, whenever you play a game, the objective is to win, right? But you have to employ a strategy, just as in any game, you employ a strategy so that you enhance your probability of winning. So the question for us then is this. Let me insert a new slide. So our choices are the following. One, always stay with your original pick, right? On the other extreme end, 3, always switch. Always switch. And somewhere in between is sometimes stay, sometimes switch. So the question for us is, which of these 3 strategies will give us the maximum probability of winning, of getting, the grand prize? So if you always stayed, what do you think is your chances of winning, the probability? Remember, there are 3 doors, right? You open one and you stay with that choice. So what's the probability of winning?
50%.
I'm sorry, Abby?
Is it 50%?
Why did you say 50%? Remember, you're always staying with your original choice.
I mean, because he opened the other door. I mean, I know that it's not that door.
Okay, does that,
So
I mean, remember you're staying. Does that really alter the probability of winning?
I guess not then, no. Yeah,
Okay.
yeah, okay, so 1 out of 3.
All right, 1 out of 3, correct. All right. 1/3. So question is, can we have a better probability than 1/3?
Yes.
Okay, yes. So definitely the always stay option is not what we're going to adopt, right? As a rational decision maker, we'll say, you know, we can improve our probability if we pick either 2 or 3. How about 2? What's the probability of winning if you sometimes stay, sometimes switch? Is it going to be better than 1/3? Yeah, I see some.
I think so, but I don't know why.
Okay. Yes. Yeah. Okay.
Yes.
It does improve. By how much? Well, it depends on the, you know, how much of the time you stay, how much of this time you switch. If the staying is closer to, you know, almost always, then your probability of winning will be closer to 1/3. But if the frequency of switching is more than staying, then the probability of winning will be closer to the 3rd option, the always stay strategy. So here's the question. What is the probability of winning if you always switched?
Wouldn't it be 2/3?
Okay, 2/3, AJ. Why'd you say 2/3?
Is because there's a 2/3 possibility that you did not pick the right door on the first option.
Okay. So, you know, that's right. So that's a complement of the always stay. All right. So if you have 2 of the doors, you know, if you always switched, there are two out of 3 that you will switch to the correct choice. So if you always switched, then your probability of winning is actually doubled compared to always staying. All right. So, you know, I mean, you know, I'm not going to show you the, there's a video that does a simulation of this game. You know, a couple of guys doing a sampling, you know, maybe they play this game 20 times and one guy uses, one person uses the always switch strategy and the other one uses always stay strategy. In the end, the video shows that the always switch strategy has more winnings than the always stay. So, you know, I will encourage you to take a look at this video to see what the simulated process is. So, which brings me to another point, you know, that when you are trying to maybe estimate something and a known number, we typically rely on statistics. That is, you take a sample, and then based on that sample, you make an estimate of a statistic that you would want to estimate. So you'll see here in this class the application of sampling technique in order for us to compute certain numbers. Okay, so those are maybe, I don't know, one might think that, hey, you know, these are not really business related examples. Yes, that might be true, but the point here is that when we make decisions that we want to evaluate information that's provided to us and analyze it in a more analytical fashion. Okay, so let me give you one last example here, and this is business related. In fact, this is a simple finance example. It's known as the Almcott case. All right, so here it is. Let me make that bigger so you can see what the situation is about. On Tuesday, software giant Almcott posted a year-end operating loss of $3.5 million. Reportedly, 1.7 million of the loss stemmed from its foreign language division. Okay, with short-term interest rates at 7%, Almcott decided to use 20 million of its retained earnings to purchase 3-year rights to Magic Word, a software package that converts generic word processor files saved as French into English text. So in this first sentence, they're talking about Almcott having this money, 20 million, and invested it in this application. All right. First year sales revenues from software was 7 million, but thereafter sales were halted pending a copyright infringement suit filed by Foreign Inc. Almcott lost the suit and paid damages of 1.7 million. Industry insiders say that the copyright violation pertained to a very small component of Magic Word. Ralph, the Almcott manager who was fired over the incident, was quoted as saying, "I'm a scapegoat for the attorneys who did not do their homework before buying the rights to Magic Word. I projected annual sales of 7 million per year for 3 years." And he says, "My sales forecasts were right on target." Okay, so the question is, do you know why Ralph was fired? Or should he have been fired? And why? Or why not? So how do we evaluate this? You start by, the 20 million investment. Should the 20 million investment have been made by Almcott based on Ralph's projections? Who says yes? Raise your hands. Who says no? Okay, Madison says no. And AJ, or why did you say no, Madison?
Well, to be honest with you, I still kind of caught up on the bat and the ball thing.
Oh, yeah, okay, yeah. All right.
And I'm paying attention, but I was just also in a little bubble with that. So honestly, I don't.
Okay. I think you got, if you're still thinking about that, maybe you can present a better solution than mine.
I'm doing I'm thinking about a Rolls Royce and a Ferrari now. I'm all the way to that point, just trying to put together. But
okay, so let's focus on this now. With the information that you have in front of you, was the investment good investment? Meaning Ralph is right that he was used as a scapegoat, or not a good investment, in which case Ralph made a poor decision before 20 million was invested. So think back for those of you who have completed finance, BA 385.
Well, after the lawsuit, are they still making the 7 million annually?
Ryan, you say, are they still making?
Like, are they still getting the 7 million annually?
Okay, so essentially you're saying that they actually made 21 million out of their 20 million investment? That's 7 times 3, right? 7 million times 3 years.
So you get $1 million after 3 years, basically, but it's not worth the same amount.
Okay, so what concept are we talking about, Phil? Yes, you have $1 million after the 3rd year, but you say it's not the same amount. In what sense is it not the same amount?
Inflation.
I'm sorry?
Inflation.
Okay, all right. So how do we evaluate this? Well, additionally, there's also this information about the short-term interest rate. So there are a couple of ways that you can evaluate this scenario. You can say, hey, you know what? If I invested this 20 million at 7% interest rate per year, invest it for 3 years. So let's instead of doing this, here I've set it up now. Okay, here's the 7% interest rate, and then the investment of 20 million, and Ralph's projecting 7 million per year. So maybe one way of evaluating this is say, hey, if I invested, this 7%, this 20 million at 7% per year, how much will this 20 million be at the end of the 3rd year? Okay, that's one. The other way of evaluating this is, as Phil said, maybe the inflation rate. Actually, we will use the 7% as a way to compute what is known as a present value. All right, remember that the 7 million now on the 1st year. So this is year 1. And then you have year 2, same 7 million. And 7 million year 3. Change that to dollars. Okay, it's not 7 million. I need one more 0. So if we discounted this back to the year 1, the 7 million at the end of year 1 will not be the same as the 7 million now. The 7 million in year 2 will not be the same or the buying power of 7 million now. So the way we evaluate this would be what you learned in finance is a couple of ways. All right, one is known as the net present value method, where you convert the 7 million, oops, added these 2 rows. You convert this back into present value. You convert this back into present value, and also this present value using the 7% as a discount rate. Okay, so here's the equation, or at least here's the function in Excel that we can use. It's called the net present value, NPV, right? And then when you type the NPV, the function will ask for what is the annual rate. The annual rate could be, you can write there 7%, or you can just pick up B4, and then the NPV function wants you to list the values of the cash flows for the succeeding periods. So we will type here 7 million for the first year, and then 7 million for the second year, and then 7 million for the third year. All right. Again,
question. Could you just click the cells?
I'm sorry?
Could you just click the cells?
Yeah, you can just do this, correct. That's correct. Instead of typing in the 7 million, so in Excel, and I tell students this, that it's best to use refer to cells rather than using constants. So was that Kianush who?
Yep, that was my question.
Right. So there are a couple of ways. Because if you use the cell addresses, then you can reuse this template by simply replacing the values in year 1, year 2, and year 3, and the template will compute. Let's do both, okay? So equals NPV. Rate is that cell, and then this is the second, the third, and then those investments. Okay, so either way, but this one is the more preferred because it will allow you to reuse the same template that will compute the present value. The other function that you can use is known as the present value. Okay, the present value. You can use the present value function if the cash flow is the same year after year. So the present value function asks for the rate over here, and then N per, meaning number of periods, would be 3 years, and then the payment, the cash flow, would be 7 million. Okay, so either way, you get the same answer. Now we can tell Ralph that, hey, you know what? The 21 million that you were projecting is really not the right number to use, because you could have invested the 20 million at 7% and probably earned, well, not probably, but will have earned more return than investing it in the software. All right. Or if you are comparing this investment versus the return, there's actually a net loss of your investment of about $1.629 million. Okay, so this is where we're talking about using analytical approach to decision making, using things that we have learned in your other classes, like finance or accounting or economics. Okay? Questions so far? Okay, seeing none, let's move on to the next. So this class will be about, as I mentioned earlier, focus on the decision-making process. So in the previous examples we looked at, there was a question or a management dilemma or decision to make. And the question for us is, what is our choice? What's our decision? What's our conclusion? The middle part is where we evaluate these scenarios using either intuitive approach or the analytical approach. And here we're talking about subjective or objective means of evaluating the scenario or the situation to get to the conclusion, recommendation, or answer. Okay. Here are some of the differences between subjective and objective approaches. The subjective, sort of more the intuitive approach, wild guesses, intuition, educated guesses, calculated risk. All right. So in decision making, we talk about decision making environments, an environment of uncertainty, an environment of risk, or an environment of certainty. You know, an environment of uncertainty is the worst possible decision environment you can possibly make. Now, when we talk about an environment of uncertainty, there is no useful information available that will allow you to make a conclusion or recommendation. So, you know, in situations where there are no useful information, that you just use a wild guess or intuition, it's probably just as good as flipping a coin or rolling a die. Obviously, when you are making decisions, whether you're talking about personal decisions or business decisions, we would want to have information, okay? As much as possible, perfect information. So if you have perfect information, then you are dealing with an environment of certainty, okay? An example might be the Almcut case. You are given information on the interest rate, the investment, and then the projection, sales projection, so you can evaluate the financial feasibility of the investment using some financial analysis, okay? So that would be on this side, the objective. This is where we really want to be at when we make decisions, using qualitative and quantitative data, use of models or simulations, and then use of direct observations. So this is what we call as data-driven or data-informed decision making. Okay, so the two extreme in decision environments I have outlined or stated. One is the environment of uncertainty, where there's no information available. And then the other extreme end is an information of certainty, where you have perfect information. Now, even in situations where you have perfect information, answers to questions, correct answers or correct decisions are not guaranteed, because sometimes we don't process the perfect information correctly. So that could lead to incorrect choice. Again, that is the case in the Almcut. Ralph had the perfect information, but he just did not process the information correctly. So he made an incorrect conclusion regarding the profitability of the investment. Somewhere in between an environment of uncertainty and environment of certainty is what we call as the environment of risk. Okay? In an environment of risk, you have significant information. Therefore, there is a probability that you can assign to your certain conditions that will prevail, and these conditions will have an impact on your decision. Okay, so this is something that we will cover when we discuss decision theory. It's not in this the first 3 weeks. I think it's on the second assignment is where we use the concept of decision theory to evaluate choices. Okay. So what is this class all about? Again, to sum up, we're talking about decision making, the use of data in decision making. And I've touched on sort of generally decision-making environments. And what you will observe in this class is that the models and concepts that we will be discussing will really talk about the cost associated with a certain action and the benefit of that particular action or decision, okay? In decision making, it is tough to evaluate cost benefit because in most cases, benefits that or the outcome of choices or actions that you make are at best probabilistic, okay? Meaning they're not for sure, but they are, you can say, assess certain likelihood. Whereas costs are typically deterministic, meaning you know what the cost will be, right? But the problem is the benefit of that action is not known with certainty. Okay, here's an example. You buy a new car, right? When you buy a new car or maybe new product, expensive product, likely you will be offered to purchase an extended warranty. Now, the extended warranty has a specific cost. You know how much you're going to pay for that service, right? But the benefit of that extended warranty is something that you don't know for sure, right? It's probabilistic. So you can do research on maybe the failure rate of a particular product and then use that information to evaluate whether the expected benefit associated with the cost of the extended warranty would be higher than the cost. Okay, so common subject areas where we will be drawing concepts, understandings from will be your accounting class, your economics, the micro and macro, the finance, statistics, and algebra in most cases. I mean, in some of the models. Now, how is this class related to business planning? Well, many of the topics that we will cover in class will have a direct feed into the development of your capstone, BA 499, which is business planning. Okay, so some of the topics that we will cover will include forecasting, decision making, probably not location planning, cost volume analysis or break-even analysis. This is a topic that you already covered in managerial accounting. Okay, we'll talk about reliability of products, inventory management. Scheduling is a topic that we will not have time to cover. Similarly, project management, we will not have time to cover that, but we will cover waiting lines theory, meaning understanding lines, and quality control. So the first topic that we will cover, not today, but in our next meeting, will be understanding the forecasting approach, why we use forecasting and why it is important for us to understand the forecasting process, because forecasting really is affects all areas, functional areas in business. Here are some of the important recurring themes that you will see in this class. Recognizing and identifying decision-making problems, responding to opportunities. We will be weighing cost versus benefit, right? And then we will be using many analytical and quantitative tools that are or were introduced in your other classes. So Excel will be a big part of this class, and that's because we will be using Excel to simplify the computational process. You will be dealing with formulas, and we will try to explain these formulas in less abstract as possible. You will learn how to develop graphs and understand the meaning that graphs convey. And then we will look at some interactive simulations, okay? So here are some of the cost-benefit examples. When we talk about inventory management, you try to weigh or balance the cost associated with more inventory versus the benefit, okay? Queuing theory, this is the waiting lines, study of lines. More servers, meaning larger capacity, and the benefit of larger capacity would be higher customer service, lesser interruption of process. But we know that with larger capacity, you're dealing with higher fixed cost, right? Reliability, we'll talk about the decision to have a higher level of inspection. When you have higher level of inspection, then the cost of defectives, passing defectives drop. But on the other hand, the cost associated with quality goes up. So we will have to strike a balance between these two. All right. So here's some more, break-even analysis and inventory management. So a typical graph that illustrates this balance between the cost versus benefit is this. Okay, this is a cost graph illustrating the cost of inspection, meaning the more inspection you do, the higher you spend on inspection. So that's this line here. The cost will go up, the cost of inspection goes up. But the trade-off is that if you spend on quality control, such as more inspection, the cost of passing defectives will drop like this green curve here. All right, so there's that trade-off we're talking about here. At some point, if we added this green curve and this yellow line, the two kinds of costs associated with quality control, you get this red curve, which we call the total cost of quality, or the total cost curve. And you will note that in this curve, the total cost is minimized at this level, all right? And that corresponds to a certain inspection level. So we call that the optimum inspection size. Optimum in the sense that that inspection size minimizes the total cost associated with inspection and the cost of passing defectives. Okay, so this theme and this graph is repeated when we cover inventory management. when we talk about queuing theory. Okay. So those are the graphs that we need to understand. Equations. We will try to explain the equations in a more understandable fashion. Okay. And then more graphs here. This is something that you will see in inventory management. We will try to explain what the slope of a line represent. Okay. And relate this to inventory management. So when you work on the assignments, you will have a better appreciation, understanding, and hopefully your Excel skill will be enhanced because these are the common Excel functions that we will be introduced to and will use in this class. The concept of relative and absolute cell address. It's important to understand the difference between these two and their use, because when you're developing an Excel spreadsheet, when you copy and paste formulas, you can take advantage of copying and pasting instead of recreating formulas for each cell when you understand the use of an absolute and relative cell address. And I will look at the use of named cell ranges to make solutions, equations, or formulas in Excel more readable. We will use lookup function in some of our problems. We'll understand how to use the if function. And then there will be lots of graphics and creating what I call as active worksheets. Okay, any questions? So I think hopefully the overview I presented gives you an idea of what to expect in this class and how to approach the different topics we will be covering from week to week. And then, plan your time accordingly. Take baby steps each day or maybe each week to work on problems.